Now that we covered the concepts of a topic, consumer and producer, it is time to learn how we can create these elements with the code. We'll use Java for these demos, and by the way, let me know if you want similar videos but for other programming languages, in case Java is not your cup of tea, or should I say your cup of coffee. I already prepared a GitHub repository where I added examples that I wanted to share with you. So this is a repository. You will find the link to this repository in the description for this video. And over here, you will find examples of producers and consumers. You can either get the inspiration for your code from here, or you can clone the project and use it as a playground. By the way, since we use Java, you will need JDK installed on your computer. I used the Java 11 JDK when running the code, but Apache Kafka supports up to Java 17. And if for some reason you don't have JDK locally, you can run the code directly from the GitHub using the code spaces. It's very convenient, at least worked for me very smoothly. Next, to communicate with Apache Kafka cluster, you will need an official low-level Apache Kafka client library for Java, what we also call a reference client, to create a producer and consumer. Know that if you plan to work with Java APIs for Kafka Streams or Kafka Connect, which we will discuss in other videos, you will need an additional set of libraries. But the Kafka client, this one, will be sufficient for producing and consuming the messages. They're exactly what we want to do today. The most convenient way of including Kafka client in your Java project will be either by using Maven or Gradle. Select the latest version from the Kafka client from the Maven repository. You have versions over here, and then choose the build tool that you use, either Maven or Gradle, or if you use something else, and then you can copy the dependency to use in your project. I am using Gradle, so let me share with you the Gradle file, which I have, not this one, the build Gradle, and here I have the dependencies which I am using to run the code I will be showing today. To run the examples, you'll obviously need an Apache Kafka cluster, and you can set up the Kafka cluster locally, or you can use one of the available managed versions. I will be using a managed version. I will be using Ivan for Apache Kafka for convenience. I like it a lot, but also for all transparency, I work for Ivan. If you want, you can also try Ivan for Apache Kafka if you want to follow exactly what I'm showing. There is a free trial which will be more than sufficient for what we will see in this video, and you can register for it, and you don't need to provide the credit card details or anything else. So it's pretty straightforward. Of course, feel free to set up your own cluster using localhost or use a different alternative. But once you have your cluster running, you're ready to create a topic. And by the way, on the topic of the topics, we have settings in Apache Kafka which will prevent automatic creation of a topic. It's called auto create topics enable, and by default usually it is disabled because you don't want to allow creating topics whenever a new message comes dedicated for topic you don't yet have. You might think it's very convenient to automatically create the topics, but you risk populating the cluster with a bunch of topics because of a variety of mistakes, typos, and so on. So ideally, you keep this property auto create topics enable set to false, and you make as a rule to create the topic before you start sending data there. In the demos, I will be focusing on a single topic, and this topic will contain events based on the activity of our customers searching or buying products in the online shop. And I will call the topic customer activity. Now, I will add the topic. We don't need to enable advanced configuration yet, so we just use the default parameters. Whatever you have, it will work. Now, with this, we are ready to create a very simple producer to send the records to the cluster and a very simple consumer to read those records. But before creating the producers and consumers, you need to specify several configuration properties so that you keep the information exchange between the Kafka brokers and the clients secure, confidential, and complete. And those extra properties which we need for connection and for the secure data exchange, I am keeping in the resources folder. When you check out this repository, you will notice that those files are not here, and to make sure that we never commit those files to the repository, I am putting them in the git ignore, because we never want to include any passwords, any keys, anything like that into the repository. You will need those files generated for your cluster. And the first property which you need to specify is the location of your Kafka cluster. If you're using the local host, most probably you will have 127.0.0.1 and then you will have port 9092, unless you have some custom settings. However, and this actually will be enough. If you're running the Kafka cluster locally, then just set the Bootstrap servers to this IP address, so to your address of your Kafka cluster, and this will be sufficient. You can totally ignore the rest of these properties, just remove them, and you can skip till the next timestamp, because you don't need to set anything else. However, if you're using a managed version of Apache Kafka, as I'm doing here, the server configuration will be taken by the infrastructure provider. However, we will need to establish a secure connection from the client. We don't trust strangers on the street, and in the same way, or even more so, we don't trust anyone on the internet. And there are different ways, different approaches we can authenticate Apache Kafka cluster. The most popular is TLS, so this is exactly what I will be using for both authentication and encryption. And kind of a TLS refresher to establish a connection between a client and a server in a secure way, we need three things to happen. First one, we need that the client needs to verify the identity of the server. And the server also needs to verify the identity of the client. And then we also want all the messages in transit between the client and the server to be encrypted. And to do this, we won't reinvent the wheel, but we will use Java key store and trust store, these files. If you're new to the whole concept of Java key stores and trust stores, this can look tricky at first, but the good thing is you don't do this very often, and once you created key store and trust store, the next time it will be easier. So in the end, we need the folder with all these files, and you can generate the key store and trust store on your own by collecting the necessary certificates from your server, and then by running the commands from the commands from OpenSSL and key tool to generate the files. You might also use a possibility if your data infrastructure provider already has some kind of CLI commands to simplify this. For example, Ivan already offers a CLI command exactly for creating Kafka Java credentials. I will provide the name of the service, username, and the password, not the password for the service, so like for your account, but the Java key store and trust store password which you want to have. And by running this command, it will generate me all the files I need. So depending on where your server is located and who is running it, your approach to creation of these files will be different, but this is what you will need. Now let's look at the code itself. So here in the folder I have several files for producers and a file for consumer. Let's start with the file producer one message. So here we will generate one message which will be sent to the cluster. Let's first run this code just to see that everything is working, and then we'll look step by step how exactly we are sending the data. So here we got a long reply, and here we logged in all the configuration which was used to establish the connection. Here you can also find all the stuff which we specified, such as our SSL protocol, the location of trust store, key store, the rest, whatever you use to establish the connection. And if everything goes well, like in our case over here, you will be able to establish the connection. And then we create a record over here, and we send a single value. We send an object with information about our customer performing an operation on some particular product. And when everything is done, we finish the process and exit. So this is producing one message. Let's look now at the code. So if we have to separate it into several steps, and I defined here 4 steps we can use. The first one will be to create the producer object. We are relying on Java Apache Kafka library, and we are using the Kafka producer class, and we are creating an object. We are using some properties to create this object where we specify, first of all, we specify everything that was part of our resources over here of the client properties. So we need the location of the server, and also if you are connecting to the remote cluster and you're using SSL, then you also need these parameters. And after that, we also need to specify how our data will be shaped, how it will be serialized when it will be sent to the cluster, in which form and shape it will be sent to the cluster. Here we just use a string serializer. And once that is done, we have a producer. Of course, we need also to know to which topic we will be sending the data, and then the data itself. Here for this example, I'm using JSON. Apache Kafka, in fact, doesn't really care if it's a JSON, if it's a string, if it's a Avro or something else. It just transmits the data to the cluster, and that's it. So you don't have to use JSON. You can also use anything else over here. And we create a message with 3 properties. Our customer does some operation to one of the products we have. And then we package this message in a record. Again, we are using producer record from Apache Kafka Java library. We package our message and we specify the dedicated topic for that message. And finally, we send the record with the method send from the producer. Producer will know now where the cluster is located, how to authenticate to that cluster, and it will take the record, and then we will also have the callback to see that everything went smoothly and we have no exceptions, and that's where we log in the information about the success of the operation. And then we flush the producer and close. So this is what we need to send one record. But now, to make sure that we indeed send the record, let's run the consumer. In a similar fashion, when we run the consumer, it will output all the properties which we are using for the connection, and then it will read the messages. And here we can see a single message which we sent for the Judy Hobbs who ordered a carrot. So we indeed received the message from the consumer side. So I will not terminate the process yet, but let's look at the code. To create a consumer, we use a similar approach as how we were doing it with the producer. We will specify the set of properties which we will need, some of those that come from the client properties, so these ones. We also need to specify how the data will be deserialized when coming from the server. And finally, there are two new properties which we are using. First of all is what is the group ID, the consumer group ID that we are using. And here I'm just using the first group ID we have. And the second one is from which offset, from which point we want to read our data. We can start from the start of the topic, we can start from the latest message available right now in the topic, or we can specify some offset which we want to use, some specific offset. We are going from the earliest point in the topic. And with those properties, we create a consumer object, we specify the topic name, where we want to read the data, and we subscribe to that topic. We can also subscribe to several topics if we want to, but right now we have only one. And then we start polling the records on some interval. And when we get the data, we output the information about the records we received. And that worked for a single item with Judy Hobbs. However, let's run another producer I have over here, which instead of sending a single item, will generate records every second. So here I specify a list of operations which are possible to do, a list of customers which we have, and a list of products that we have. And then we do very similar stuff as we were doing with the previous producer, with an exception that here we create a bit of a nasty while true loop to imitate a continuous flow of data, and we generate the messages on a regular basis, and then we go and use a sleep timeout. You can change this to the timeout you want to have. I felt that 1 second gives enough time to observe what is happening and doesn't go very, very quick. However, if you want, you can remove this. Yes, finally, we again log the results. So if we run this producer, then we start sending and receiving, start sending the data, and here you can see that we are sending data to variety of our customers now. It's not only Judy Hobbs. And our consumer, on the other hand, reads all the data from the cluster. We here also provide information about partition and offset. However, those we will discuss in the next videos. And this is the code which you need to use to create a simple producer and a simple consumer. In the next video, we'll look at how the topic data is stored and in particular what are brokers, what are partitions, and what is the role of the keys. Leave any questions or comments you have in the comment section below, and if you enjoyed this video, please like it and subscribe to the channel.